think that the key factors in assessing a battery's impact, as well as assessing any product's impact, are to consider the entire life cycle of the battery. So starting with the extraction of raw materials up to the end of life, or what we call from cradle to grave. For each of the processes included in this life cycle, it's important to collect all the data necessary and that the data are high quality, and also to consider all the different environmental impacts that might be relevant for the battery. For the batteries, the hotspots, the steps in the life cycle that have the highest environmental impact are the mining of the raw materials, and also the energy consumption during the processing of these raw materials, and the manufacturing of the cells and all their components has a relevant contribution to the overall environmental impact of batteries. In general, the environmental impact of recycled materials is lower than the impact of virgin production, as for the virgin production you need mining, there will be some ecosystem destruction, there will be pollution of local ecosystems, and recycling can reduce these impacts. The impact of the process itself is generally not that big, and it's also important to take into account that you need to do something with the batteries at their end of life, so recycling is a good option compared to alternatives such as landfilling or incineration, which will also cause environmental burdens. I think one of the important things there is that often an ideal situation is considered where batteries are recycled at their end of life, while in reality it will depend a lot on customer behavior. For example, customers might keep batteries in their drawers for a long time, or if it's a battery in an EV, vehicles can get exported illegally from Europe and are not necessarily recycled properly, so it's important to gather data on the actual situation, and it's not always very easy. It always takes some time to implement methodologies, takes some time to assess the impacts of the new chemistries, and yes, there can be some issues. For example, nanomaterials are used in batteries and their environmental impact is not yet completely certain, so toxicology assessments need to be done. At the moment, the methodologies that are implemented in LCA software consider the chemistry of emitted substances, but they do not really consider their size, while this also has an impact on their toxicity. Research is going on this topic and other topics related to batteries, but of course it takes a while before those are implemented and all the impacts of the batteries can be fully assessed.